Before we begin to describe the basic operation of the Flaker and DCM models, let's look at some of the features and benefits that make Hoshizaki machines so dependable and serviceable. Removable panels make regular maintenance checks and servicing much easier. A solid-state sequence timer provides automatic control over the continuous ice-making process. Hoshizaki Flakers and DCMs utilize an internal auger system with a direct drive spline-coupled gear motor for dependable operation. A fully insulated stainless steel evaporator provides a durable freezing surface. Anti-magnetic stainless steel is used to eliminate pitting and corrosion on the evaporator and auger surfaces, helping increase efficiency and extending component life. The bearings are sleeve-type alignment bearings. The carbon resin bearing material has a graphite base to provide lubrication, eliminating possible grease contamination. The auger is driven by a sealed gear motor assembly, which is protected by two overload sensing systems that protect against undue stress. A unique low-water safety device developed by Hoshizaki shuts the unit down automatically if the float switches fail to detect water in the reservoir. The unit will restart the ice-making process only when the water level is restored. Removable panels, a solid-state sequence timer, anti-magnetic stainless steel evaporator and auger, carbon alignment bearings, a sealed gear motor with overload protection, and a low-water safety device. Just some of the features and benefits of the Hoshizaki Flaker and DCM models that help make your job easier. Now, let's look at the basic sequence of operation of the Hoshizaki Flakers and DCMs. The complete startup and shutdown process for the Flaker is operated by a series of timing circuits designed into the solid-state timer board. With the power switch on and the flush switch in the ice position, the inlet water valve opens, allowing water to fill the reservoir. The ice-making process will not begin until the reservoir is filled. When the dual float switches indicate a full reservoir, operation is turned over to the bend control magnetic proximity switch, and if it's closed, the unit begins ice production. At this point, the gear motor and condenser fan start up. Should the gear motor not start, a gear motor protect relay will automatically shut the unit down to protect against any component damage. If at any time during operation the sealed gear motor should experience stress which causes an excessive amperage increase, a manual reset gear motor protector will shut the unit down. After 1 minute, the compressor starts. This delay allows any ice left in the evaporator cylinder to be cleared. As the refrigeration system cools the water in the evaporator cylinder, ice begins to form and is extruded within 2 to 5 minutes. Ice production will continue until the bin is full. Once the bin is full, ice pushes against the bend control, which opens the magnetic proximity switch and begins the shutdown process. On the M model Flaker, the gear motor, compressor, and fan stop within 6 seconds after the bend control indicates a full bin of ice. A time delay is used in the smaller Flakers and DCM units to allow the gear motor to clear the evaporator of ice. On these models, 1 minute after the bend control switch opens, the compressor stops. 1 minute later, the gear motor and condenser fan stop. The unit will now sit idle until the ice is moved away from the bend control, which will cause the proximity switch to close and restart the unit. Unique among Hoshizaki Flakers is the automatic flush period, designed to provide cleaner operation and longer bearing life. The automatic flush is operated by a 12-hour timer. The flush feature can also be operated by the manual flush switch when periodic cleaning or maintenance is required. When the flush timer or manual switch is activated, the Flaker unit cycles off within 2 minutes. 1 minute after either switch opens, the compressor shuts down, followed a minute later by the gear motor and condenser fan. Next, the flush valve opens, allowing the complete water system to drain. While on the flush timer, the unit remains off for 15 minutes. Any ice remaining in the evaporator melts, and the evaporator walls and mechanical seal are completely flushed out. During this time, the inlet water valve will not be activated. During normal operation, the auger rotates inside the evaporator cylinder to break ice away from the cylinder walls and move it up to the extruding head and cutter. Because the auger is one of the major moving parts in the ice maker, it must be checked periodically for excessive bearing wear. Although Flaker bearings are constructed of carbon-impregnated resin, they may wear due to high mineral or silicon content in the water. If not replaced, excessive bearing wear may cause damage to both the auger and evaporator cylinder. To remove the auger for inspection, drain the water system, remove the clear ice chute head and chute bracket. Next, remove the stainless steel bolt that holds the cutter to the auger. Replace the bolt and use it to rock the auger back and forth to check for excessive play. To check for bearing wear, attempt to slip the 20/1000 inch feeler gauge available through Hoshizaki into the gap between the auger bearing surface and bearing. If the bearing gap is more than 0.02 inches, replace both the top and bottom bearings. To remove the auger for bearing replacement, remove the Allen head cap screws and water seals which hold the extruding head to the evaporator cylinder. Using the bolt and a large washer or the cutter head installed upside down to hold the auger, lift the auger and extruding head up out of the evaporator cylinder. When the auger has been lifted out, remove the extruding head and visually inspect the auger bearing surface for wear. The sleeve bearings are pressed into the extruding head and lower housing. To remove the lower housing, remove the Allen head cap screws which secure the evaporator cylinder to the housing. Loosen the belly band screw and lift the evaporator up about 4 inches. Then tighten the screw to hold the evaporator in place. The housing and cylinder are sealed by an O-ring. Care should be taken to protect the O-ring for reuse, or replace it if necessary when reassembling the unit. Remove the bolts at the base of the housing, and remove the housing to replace the lower bearing. Have the bearings repressed and replace the parts in reverse order.